A 1.2 kilogram block and a 1.8 kilogram block are initially at rest on a frictionless horizontal surface. When a compressed spring between the blocks is released, the 1.8 kilogram block moves to the right at 2 meters per second as shown. What is the speed of the 1.2 kilogram block after the spring is released? So to solve this problem, we need to employ two concepts. The first is the law of conservation of momentum, which tells us that the system momentum before an event is equal to the system momentum after an event. And the second is simply the definition of momentum, which is mass times velocity. So we're going to start by calculating the system momentum before the spring is released. So we're told that the 1.2 kilogram block and the 1.8 kilogram block are initially at rest, which means that the initial system momentum must be 0. So we know that momentum is mass times velocity, and if both blocks have a velocity of 0, in other words they're at rest, then the initial system momentum must be 0. Now we can apply the law of conservation of momentum to solve this problem. So we know that 0 is going to be equal to the final momentum of the system, or the momentum of the system after the spring is released. That momentum will consist of the momentum of block 1 plus the momentum of block 2. So this final momentum here will be the momentum of block 1 plus the momentum of block 2. Now for this problem, I'm going to consider to the right to be the positive direction. You could consider left to be the positive direction if you wanted to, and you would still be able to get the correct answer. So let's take this up over here. We'll have 0 equals momentum 1, so the momentum of block 1, which will be the mass of block 1, times the velocity of block 1. Now we're going to add that to the mass of block 2 times the velocity of block 2. So now let's plug in some value. Actually, before we plug in any values, how about we solve for the velocity of block 1, since that's what we're looking for in this problem. So we'll subtract mass of block 2 times velocity of block 2 from both sides, and then we'll divide both sides by mass 1 to leave us with velocity 1 equals negative mass 2 times velocity 2 divided by mass 1. So now if we plug in our values, we'll have negative 1.8 kilograms times positive 2 meters per second. So I'm considering to the right to be positive, so this rightwards velocity is positive. Then we divide by mass 1, which is 1.2 kilograms. These kilogram units cancel. We're left with units of meters per second, which makes sense because we're looking for a velocity. And if you complete these operations, negative 1.8 times 2 divided by 1.2 gives us a final velocity of negative 3 meters per second. So that means that the velocity of block 1 is to the left. So it is in the opposite direction to the direction that we considered positive, which was to the right. In this case, we're just looking for the speed. So we can get rid of that negative, just take the magnitude, which is 3 meters per second. So the speed of the 1.2 kilogram block is 3 meters per second after the spring is released.